6.3 Chatellier's principle. The definition is when a system is disturbed. Okay, either you are increasing or decreasing something, the system will gain its chemical equilibrium to counter the effect of those changes. Okay, so the first factor is concentration. It is either we increase or decrease any reactants or product. The second is temperature. Well, for isothermic, okay, azo means heat is released at product site. For endo, heat is absorbed at reactant site. Just be careful, guys, that when we are talking about azo or endo, we are talking about heat, not energy, like in physics. For pressure, is to calculate. The third factor is pressure. We have to calculate the total mole of reactant and product. Okay, please write a note. Never ever consider solid or liquid. Okay, remember, right? Kc and Kp. We don't include solid and okay. So for example, like for this ferromine solid and H2O in liquid. Okay, we don't consider it, so just write the total mole as 0. So 0 plus 0, so the total mole is 0. For Fe3O4, it is solid, so the mole is 0, and for H2, it is a gas, so the mole is 4. Okay, so the total mole for the product is 0 plus 4, which is 4. Okay, so which one has a higher pressure is the one that has higher mole. Okay, so which is obviously your product. So product has higher pressure. The fourth factor is the addition of inert gas. Okay, you just have to remember the explanation. Okay, for constant pressure, the total pressure is constant and the partial pressure will decrease. But for the constant volume, well, the total pressure is increased, the partial pressure will remain constant. And the last would be the catalyst. For catalyst, there would be no effect. You just have to state that catalyst only cause reaction to proceed faster. So let's try our first equation. So let's say that I add oxygen. Okay, so I add oxygen in this whole equation. So we've got 3 mole oxygen at the reactant site. Already, right? So reactant would has many oxygen while product has no oxygen. So in order to balance the reaction, we have to shift, okay, the equilibrium to the right. Okay, because at the reactant we already has many oxygen, right? But for at the product side we don't have any oxygen, right? So we have less oxygen. Okay, remember that we need to be generous, right? So we need to donate from many or more to less. Okay, so that's why the equilibrium shift to the right. So for explanation, okay, this is my answer scheme. Okay, you just have to explain the equilibrium shift to the right because we need to re-establish to reduce the amount of O2 in reactant because we are adding oxygen, so which means that we need to counterattack this disturbance. So by adding, so we need to counterattack by making or reduce the amount of oxygen. Okay, because we need to balance this overall equation. Alright, so next, remove NH3. Okay, so we got remove this NH3. So the equilibrium gonna shift to the left. Okay, because we don't have NH3 anymore in the right-hand side. So the equilibrium will re-establish to, okay, now the disturbance is we remove. Now we need to add it again to increase the amount of NH3. Increase the temperature. Okay, so the question will give you whether the reaction is in endo or isothermic. So this is a negative, so means this is an exothermic reaction. So refer back to my note. Okay, so exothermic means, where is it? Okay, we are releasing heat at product site. Okay, so when heat is released, then the product side is hot, while the reactant side will remain cool. Okay, so what's gonna happen when I increase the temperature is, okay, so when I increase the temperature, let's say that I introduce a fire to both sides. Okay, excuse my fire. Okay, so now which side we're gonna be hot even more? That would be our product, right? Okay, so product will become more more hot, so we need to balance it. So we must move from hot place to cool place. Okay, so when you are feeling hot, then you need to cool yourself down, right? So the equilibrium will shift to the left. So you just need to explain the reaction is whether endo or exo. So this is exothermic reaction. The equilibrium will re-establish too. Okay, now we increase the heat, so we need to counter attack, increase the temperature by decrease the heat, or you can say reduce the heat again. So next we are adding water. Okay, so we are adding water. So this one at the product side we already have 6 water, right? So this one has 0 water, right? So let's say that I keep on adding water to both sides. So this side will become or will has more H2O, and this side will has less H2O. Okay, so then the equilibrium will need to be shift to the left. Okay, so the equilibrium will re-establish to, okay, we disturb the equilibrium by we adding H2O, so we need to counter attack this to reduce the amount of H2O.